Welcome to Lesson 3. In this lesson, we'll provide greater exposure to .NET concepts and we'll explain some of the key relationships between namespaces, assemblies, the common language runtime functionality and its behavior, and we'll also talk about security. So the topics for this lesson are Introduction to Namespaces, .NET language topics, the Common Intermediate Language, or CIL. It used to be referred to as MSIL, Microsoft Intermediate Language. And then we'll also talk about metadata, assemblies, building CIL, security, garbage collections, and of course we'll also go ahead and talk about the common language runtime and application domains. One of the things that you need to realize as a COBOL programmer is that for you this is going to be a completely new paradigm in application development. Many of your colleagues may already be used to using Visual Studio, previous versions of Visual Studio, VB.NET or C#, so they may be a little bit ahead of the curve than you are. But trust me, this is not a difficult thing for you to work with. So let's get started. First thing that you need to know, and again, you've heard me talk about this before, is .NET allows you to create applications using a number of different development languages. Now, over the years, you've heard many people, kind of bash COBOL a little bit. Oh, it's old, it's not going to be around. Well, COBOL still lives. COBOL still is a viable language. And again, what this does is it gives you the ability to use the right tool for the right job. It's especially important when you realize that there are many millions of lines of COBOL code that are out there that are still viable, that have been remediated for year 2000, and they have a life going forward. So you need to understand that COBOL is not dead. The one thing that Fujitsu has done, and it's really cool, is they have leveraged the .NET technology and given COBOL an ongoing future, moving ahead into the newest technologies. So the foundation for all of this is called the .NET framework. The .NET framework can be thought of a library of programs that you can leverage. It's a class library and it has many classes that are embodied with it. Now, don't worry if you don't know what I'm talking about here in terms of classes, structures, interfaces, enumerations, and delegates. All of those things will become abundantly clear to you as we start moving through the rest of the training. Some of the framework classes are very robust. They contain many methods and properties and other members. And you're going to see exactly how to exploit all of those things as we move forward. When you start working with the .NET framework, you're going to pay real close attention to a thing called namespaces. Namespaces provide a very logical, high-ordered grouping of all of the components in the .NET framework. And as I said, everything is grouped together, and it's easy to drill down into all of the various categories of classes and methods and properties that are available to you in the .NET framework. Let's go ahead and cover a few terms. So let's start with class. Classes describe both the properties and behaviors of objects. Properties contain the data that are exposed by the class. Behaviors are related to functionality of an object and are defined by the public methods and events of a class. Collectively, the public properties and methods of a class are known as the object interface. Classes themselves are not objects, but instead they're used to instantiate or create objects in memory. The next term I'd like to cover is object. An object is the instance of a class that is unique and self-describing. The next term I'd like to cover is value types. A value type stores data. Simple value types include integer, floating point number, decimal, character, and Boolean. Now that we've covered a few essential terms, let's get back to namespaces. The .NET Framework Class Library is a library of classes, interfaces, and value types that are included in the Microsoft .NET Framework. The library provides access to system functionality and is designed to be the foundation upon which .NET applications, components, and controls are built. In this hierarchical representation, you can see how there are relationships between the various classes. The way we talk about these classes is like this. Let me drill down a bit. If I wanted to reference services here, I would say system.web.services. Notice that system is the root of the tree and that everything seems to spring from this point here. Let's discuss what we're looking at. In the previous slide, you noticed that system was the root of the tree. In fact, system contains fundamental classes and base classes that define commonly used value and reference types, events and event handlers, interfaces, attributes, and processing exceptions. Other classes provide services supporting data type conversion, method and parameter manipulation, mathematics, remote and local program invocation, application environmental management, and supervised of managed and unmanaged applications. So you see here that system is extremely robust. It has a lot of classes that are available to it. There are a lot of things that are inherited from system. So for example, system.data is out there. You see it out there. System.data contains classes that constitutes most of the ADO.NET architecture. The ADO.NET architecture enables you to build components that effectively manage data from multiple sources. In a disconnected scenario, such as the Internet, ADO.NET provides tools to request, update, and reconcile data in multiple tier systems. The ADO.NET architecture is also implemented in client applications. And again, all of that comes from some inheritance from the system namespace. Let's move on to Microsoft Intermediate Language, or MSIL. MSIL is also referred to as CIL, or Common Intermediate Language. When compiling to managed code, the language compiler, like the NetCOBOL compilers, C# or VB.NET compilers, translates all of your source code into the Microsoft Intermediate Language, or MSIL. MSIL is a CPU-independent set of instructions that can efficiently convert to native code. Now, MSIL includes all of the necessary instructions for loading, storing, initializing, calling methods, and all of the other instructions necessary for arithmetic, logical operations, control flow, direct memory access, and other operations. Now, before MSIL can be run, it must be converted to CPU-specific code, usually by a just-in-time or JIT compiler. Okay, here we see a very, very rudimentary COBOL program. When you compile your COBOL code to MSIL, it actually looks like this. When any .NET compiler produces MSIL, it also produces metadata. Metadata describes the types in your code, including the definition of each type, the signatures of each type's members, the members that the code references, and other data that the runtime needs to use at execution time. So what we're talking about here is the type's name, the type's visibility, any interfaces that the type implements, methods that the type implements, properties that the type exposes, and events that the type provides. Metadata includes attributes and values that are stored in the metadata that can be read and used to control how the code executes and behaves. The MSIL and metadata are contained in a portable executable, or PE file, that is based on and extends the published Microsoft PE and Common Object File format. This format, which accommodates MSIL or native code as well as metadata, enables the operating system to recognize common language images. Now, the presence of metadata in the file along with the MSIL enables your code to describe itself, which means that there's no need for any special type libraries or interface definition language, or what is called IDLE. Now, the runtime locates and extracts the metadata from the file as it's needed for execution.